Hello everyone. Today topic is landforms in this geography. In previous video we have seen the lithosphere, that is introduction. We seen interior structure of the earth, layers of the earth, materials of the earth and crust, rocks and minerals, classification of rocks. And today the second topic is landforms. So we are going to see in this features like mountains, plateaus and plants on the surface of the earth are called landforms. Landforms can be arranged in a hierarchical order. Continents and oceans form the first order in the hierarchy of landforms, and the top geographical features such as a valley or sand dune the lowest. First we are going to see the landforms of the first order, oceans and continents. The seven continents, North America, South America, Europe, Africa, Asia, Australia and Antarctica together constituted only about 29% of the total surface area of the earth. Oceans occupy the remaining about 71%. Oceans, the Pacific Oceans, the Atlantic Oceans, Indian Oceans, Arctic Oceans and the Southern Oceans are the largest water bodies on the earth. It is believed that relative position of the continent and oceans have changed over time. The theories explaining the distribution of oceans and the continent belongs to two groups of theories. The contractionist theory and theories assuming horizontal displacement. This is theory. The best representatives of contractionist theory is the tetrahedral theory of L. Green. In tetrahedral theory, what is explaining? This theory is based on the concept of cooling of the earth and its resultant distortion of shape. Green has argued that the actual shape of the earth resembles a tetrahedron with its narrow apex to the south and a depressed face on the top north pole and three depressed faces on the sides. The continent occupy the raised edge of the tetrahedron while the oceans occupy its depressed faces. Green argued that as the earth cooled, its volume must have reduced and the crust of the earth could have become solid first of all. Further heat loss would have continued from the interior, causing the reduction in earth volumes. As the surface area of the solid crust could not change with the cooling, the reduction in its volume must have distorted the shape of the earth to the tetrahedron, a shape having a very low volume for a given surface area. The raised edge of the tetrahedron become continent and the depressed faces become oceans. Although it appears logical, Green's theory did not get much support. Yes, it has been argued that while rotating on its axis, the Earth could not attain an unstable shape of the tetrahedron. A sphere is the most stable shape for a mass rotating on its axis. Next one is continental draft theory. Very important. This theory put forth by Alfred Wegener, who believed that at one time all the continents of the world were joined together as a single landform Pangaea that got frustrated around the Carboniferous period about 200 million years ago, and different blocks those formed moved away from each other and produced the present day distribution of the continents and oceans. Evidence supported in view of this theory included fossil evidence. Similarities fossils in areas far apart from each other today. Climates in the past has changed. All continents can be joined together like pieces of a zigzag puzzle. Fold mountains ranges running parallel to the coasts of the continents. The supercontinent of Pangaea consisted of two parts, a northern block called Laurasia and the southern block called Gondwana land, both separated by a shallow sea called Tethys. The Pangaea was surrounded by an exhaustive ocean called Panthasalar, while Pangaea was made up of lighter silicate matter. The bottom of Panthasalar was made up of higher density cementic matter. Wegener has argued that Pangaea got fractured under the influence of differential forces, tidal force and gravitational force, into different blocks which moved like drafts over sea in different directions. These blocks have formed the present day continents and the oceans have occupied the intervening spaces. Wegener emphasizes that the advancing edges of the continents were obstructed by the bottom of ocean, which led to formation of fold mountain ranges parallel to the coast. Although beginners collected a lot of evidence to support this theory has been criticized on many grounds. The differential forces invoked by him to explain the fragmentations of Pangaea and movement of continental drafts over Sima do not seem strong enough to cause this draft. Displacement of higher density semantic oceans bottom by lower density sila continents has also been questioned. Though the theory of continental draft was criticized, the idea of horizontal displacement got new support from studies in paleomagnetism, ancient magnetism in igneous rocks, and seafloor spreading. Volcanic rocks containing magnetic elements get magnetized by the magnetic field of the earth. Such magnetism is permanent and the polarity of such rock magnets remains unchanged even if the magnetic field of the earth changes subsequently. Such magnetism is called paleomagnetism. Plate tectonics theory. This is a newer theory. This is a newer theory explaining the distribution of oceans and continents. According to this theory, the lithosphere, that is, the solid crust of the earth, is divided into a number of relative rigid plates. A plate may be made up of either continental or oceanic lithosphere or a combination of both. These plates rest over the molten asthenosphere like floating rocks due to convection currents or convection plumes originated in the ionosphere. The lithospheric plates move in various directions. This moves plates of has been responsible for the present distribution of oceans and continents. Plate tectonics not only explaining the distribution of oceans and continents but also attempts to explain a number of other phenomena such as formation of fold mountains, ocean trenches, volcanic activities and earthquakes. Most of these phenomena are associated with the edges or the margins of the plates.